See. What is VS? 13.4. Open circuit voltage will be the voltage here without the load, right? Is this a load or no? It's not a load, right? It's just part of the circuit. How do you want to approach this problem? What are the methods we have learned? Node, mesh? Yeah? So node uses what? KCL? Mesh uses KVL? Which one would you like to use? Either one's gonna work, right? Let's do mesh. If you want to do mesh, let's do mesh. Mesh. Here's I3 minus 13.4 plus I1 minus I3 What's the voltage though? We have to assume a voltage across it, which is okay because we know I2 already is given. I2 minus I3 is given. So how do we do that? Delta V. Let's assume V1. Let's just do V1, V2. V2 minus V1 will be plus minus from right to left, right? So it's going to be the voltage by following the current's direction. That'll be plus minus, so we put a plus in front of it. That's V2 minus V1. And then this guy is I3 minus I1 times 40. What else can we do? So I2 minus I3 is 110 milliamps, right? Any other thing we can do? V1 over 15 is what? Right? And V2 over 10 is there anything is redundant here? This one? Because I don't know, if there's something redundant you will figure out later, but now we have I1, I2, I3, V1, V2, right? 5 variables. I got 6 equations. It's okay. Eventually you'll find out one of them is redundant, but it's alright. We'll figure things out. What's that?
I mean,
Because when we trying to address here, we have all the voltages, but we didn't use V1, right? For the first equation. And for the second equation, we do use the V1. I2 minus I1 times 15 becomes V1, so probably this is redundant. but we haven't addressed anything here, right, with V2, because when we come to the second mesh, we go through these two currents with this guy, and then we got this voltage, then we directly used I2 times 10. Oh yeah, I2 times 10, but we didn't do anything with V2. Same to this one actually. That's not a problem though. We can definitely solve for that one. I mean, did you list the what's that?
So how do you do V2 over 10 equals I2? Don't you have to subtract the voltage on the other side?
Oh, it's not ground. That's right. Yeah, good point. Good point.
Ground there.
I haven't finished this yet, right? So the third mesh, the second mesh, I2 minus I1 plus this, then plus I2 times 4, right? Okay. If this is ground, V2 and ground, the voltage difference will be V2 overall, so it's divided by 14 instead of 10, right? You got a V2, you got 0, so the overall drop across it is V2, and you have 14 ohms in between. So this is I2, right? That's I2, so the same current. Same current, so we can use Ohm's law because the same current. If they use a different current, you cannot directly do this, right? Did you list the same question, same equations, or the equations are different? Let's keep moving and see if we can solve anything here. I really want to figure out which one is redundant here. Probably the three here can be combined and converted into one, right? Because we have V1, V2, just plug in so you can cancel V1, V2. So got 4 equations and 4 variables. I1, I2, I3. Let's see. Let's get into it. No problem with the first one, so let's list I1. Here, 40 I1s and 15 I1s. How many I1s do we have in total? 55. I2, 15, right? I3, 40. What's on the other side of the equation? Just double check. No problem, right? Okay, no problem. It's 13.4. The second one, can we just plug in these numbers? It's gonna be a lot of stuff. So V1 equals 15 times I1 minus I2, and V2 equals 14 times I2, right? Just plug in. So that equation becomes I2. There's another way to look at it, because these two equations, combine them, you can cancel V2 and V1 here, because this is V1 minus V2, this is V2 minus V1. If you combine them, and they will be gone. So in that case, actually we don't need this anymore. Did you see that? You can even simplify it. There are just multiple ways to solve this linear equation. So if we don't keep moving forward with these ones, however, we just directly add the left side of the equation and the right side of the equation for these two, and these are gone. This will be gone. Do you see that? Okay? So let's make it easier. Let's combine these two, okay? Add on both sides of the equation. Let's label it. 1, 2, 3. This is from 1, right? And then you have 2 plus 3 on both sides of the equation. These are gone. It will be gone. And you're having I2 minus I1 times 15. This is gone. Plus I2 times 10 plus I2 times 4 plus I3 times 26. And this is gone, right? Add it together, it's gone. Plus I3 minus I1 times 40, which is 0. Let's take out the coefficients for all the i's. I1 minus 15 minus 40, this is minus 55, right? I2, 15, 10, 25, 29, I3, 26 and 40, 66, right? Just think about the matrix. You already have two equations, and third one, which is this guy, it becomes I1 times 0 plus I2 times 1 minus I3 times 1, which is 110 milliamps. So 3 variables, 3 equations. Right? 1, 2, 3. Right? So what's the matrix A? The coefficient matrix. 55 minus 15 minus 40 here, minus 55, 29, 66 here, 0, 1, minus 1. What's the matrix B? It's 13.4, 0, 0, and 110 times 10 to the negative third power. And the way we solved this linear equation is A. So the X, the variable matrix is always the variables. I1, I2, I3. This is not a linear algebra class. If you haven't taken that yet, just remember this procedure, this workflow. Pretty simple. During the exam, you can also use this one instead of substituting variables. It will take you a lot of time. So you can definitely list all the coefficients and put in your calculator to calculate for matrix like this. So what's going on here is I'm gonna go through this again. So AX, these are matrix equals to another matrix. So the way we solve for X, matrix X, is we times the inverse matrix on both sides of the equation. And this one equals the unit matrix, which times anything is still that thing. So this one times X, still X. So that's why you can ignore it. That's why we put an inverse matrix on the left, because the inverse matrix times this one, it doesn't like other multiplication rules. You can move all the numbers around. For matrix, you can only put on the left. So left times right will be the give you a certain result, and if you put on the right, will be sometimes you couldn't even calculate it. Sometimes it give you a different result. So it's going to be a different story. So we have to keep on the left. And it's not changing at all. We just remember that's a procedure. Just keep doing that. You times inverse matrix on the left on both sides of the equation. Okay? That's what we always do. And you know that because we can combine these two, because it's next to A. So the inverse times A. The inverse matrix times the original matrix will give you a diagonal matrix like this with all the ones, which times X, still X. That's why we want to do it. And this becomes A inverse times B. And we can calculate this easily. And because this is canceled, because this times x is still x, so we can cancel the a on the left and only have x left. So x is this guy, so all the currents listed in the column matrix. Eventually you calculate this guy, you can find the column matrix, you can align it with all the i's, so you can directly get all the i's. So the next step is just go back to the calculator, right? Go to the calculator. Let's find a calculator. I think it's on the website, right? This one, matrix solver. Okay. So in order to find out i's, we need this times this, right? So first we have to type this matrix A in here. It's 3 by 3. It's 3 by 3, which is 55 minus 15 minus 40 minus 55, 29, 66, 0, 1, minus 1. And the B matrix is 3 by 1. Which is 13.4, 0, 0.11. So we have to find the inverse matrix of A. Right, there's a calculator. Inverse times let's try to do the inverse first. Okay. Here's the inverse, right? Inverse. And copy to A. Here's the inverse matrix. Then let's do A times B. These are all the currents. So this equals 0.57, 0.41, 0.30, I think. Okay. So all the currents are calculated. So you can easily find out V2 by doing I2 times 10 and I2 times 14. So V2 is VTH equals I2 times 14 ohms, which is 0.41 amps times 14 ohms, which is 0.41 times 14, 5.74 volts. So we got a voltage. The voltage is VTH because that's the output. The terminal voltage without the load, that's going to be VTH. That's VTH. So how to calculate, how to find out RTH? RTH. What are the steps to find out RTH? Remove the load, assuming there's no load. Okay. If you find out the process, I don't have the copy yet. The copy is only showing a different problem here. I don't have it. I don't think this is the load, okay? I think the load is not connected, it's already disconnected from here. So assuming that this guy is not the load, let's find out the RTH. So the load is already removed. So when we look backwards, what should we do for the current source and voltage source? Remember? What are the steps? The two steps? Or maybe one is the step 2. So step 1 is remove the load. Step 2 is short or disconnect the current source. So current source should be disconnected because it has a pretty high internal resistance. It's equivalent to disconnect the circuit. So for voltage source, you should short it because it's super low internal resistance. It just replace it with a wire, right? So this guy is replaced by a wire. Disconnected. 10, 4, 15, 40, 26. So looking backwards, right? Looking backwards. Looking backwards. How do we deal with it? So this is gone. So going here, split. These are in the same branch, so you can directly add them together. So split into 2. It's going to see a 14 ohms and 26 ohms. How that works. It's shorted. These two are not doing anything. If it asks you to calculate RTH, I'm not sure. If it's asking you to do RTH, these two are shorted. So if you look backwards, these two are not doing anything. It's not there. So the way to analyze it, you imagine there's a testing current going in there, right? Splitting. It won't go through these two resistors at all. It will directly be shorted. It's going to go here. These two resistors are shorted by this wire. Can you see that? It's not doing anything. It's getting shorted. So eventually, what you are getting is RTH becomes 26 in parallel with 14. That's it. So if you have RTH, you have VTH. You can get everything, right? So VTH in series with RTH. If it's asking for Norton, it's converted to Norton, and you don't have to recalculate it. This is Rn, this is In. So In equals what? VTH over RTH. So if you know the VTH and RTH in here, you can directly convert to here without recalculating everything. That clear for this problem? Hopefully it's going to give you a right answer. I may make mistakes, I don't know. It works? Okay, cool. Another one I have to go through because I know you will stuck there for a little bit. And I want to use 2 different methods to show you that how to solve for this problem. This guy. So RO is the load is adjustable. It's a potentiometer adjustable resistance. It's a voltage control current source, so it's labeled as V delta, but it's actually a current source. And as a 4 ohm resistor has a voltage drop of V delta, it's the same value. 5 ohms. V 85 volts. I want to show 2 different methods to calculate it. The first one is, so eventually what's the goal here? The goal is to convert it to the equivalent circuit. Doesn't matter if Thevenin's or Norton's equivalent circuit. It's going to be an equivalent circuit. So if we find out VTH and RTH, we will be able to get a Norton's as well. And remember, what is a Norton's current? It's basically just as a short circuit current. If you have a circuit like that, doesn't matter what is in this black box. That's a black box. Doesn't matter what is in there, right? You just connect these 2 terminals, and that's called short circuit current, ISC, which is this Norton's current. Something we have to remember. Okay, that's it. That's exactly IN. So having that, keep that in mind. Here's the black box. It has dependent source. So if you remove the load and looking back, yeah, I can short this guy, no problem. What should I do with these 2? You're hitting a wall, right? So that's for RTH. What about VTH? VTH. You should be able to find a VTH just by removing this guy, right? VTH is easy because you have this voltage source, you have these dependent sources. Okay, just use the mesh. You will eventually find out the voltage here, no problem. So find VTH is easy. So what about RTH? Remove this guy, looking back. What do you do with these ones? Right? So if you do that, if you remove it and looking backwards, you have to use method 1 for RTH. We're talking about RTH, okay? So method 1, remove RO and looking backwards. Definitely you should short this guy because that's the ideal current voltage source. Like what we said, this is internal resistance 0, we just short it. What about these 2? You couldn't do anything to it. Cannot proceed. So in that case, we assume so this is removed, okay? We assume a IT, a test current, into it by apply a testing voltage. We don't have to know what they are. It doesn't matter. It's 1 volt, 1 amps, doesn't matter. So if we inject a current into it and we know the voltage here, if we treat everything here as a black box, eventually if we can find out VT over IT is something, so that value will be RTH, right? Because when we look backwards, it's basically we assume there's a little current going through, so we are trying to follow the direction of the current to find out resistance. It's the same concept. We just didn't use a VT over IT. We just look at the current flowing and directly use the resistance. However, here it's difficult to do so. That's why we should assume a VT and IT. VT and IT here. So it's going into it, and eventually we don't need to know the values. We just find out the division, and the result should be RTH. Okay. Let's see if we can do it. So we assume this point is V1. What's the time now? Right. What's next? Node voltage method. current going into it, this current is 85 volts, 85 minus V1 over what? 2. It's going to be current going there. And we'll assume the two currents flowing out. So the first one will be V1 minus this guy. V1 minus this voltage, and divide by 5 will be the current here, right? Then here, because here's VT, here's VT. Oh, sorry, I made a mistake. Because we are looking backwards, we should short this guy. Remember? We are doing RTH. This should be shorted. So no 85 anymore. It's going to be 0, 0. So this is shorted. It's a wire. We are doing RTH. Ideal voltage sources should be shorted. You assume it's a short circuit because the internal resistance is super low. You are not calculating any like voltage or currents or any combined effects from all the sources. What you are looking at right now is just resistance. And this one, if you have someone sitting here and looking backwards, this one at the person's perspective is basically just a 0 volts, just a wire, just a wire. We are looking at the resistance, not the voltage. That's why it should be shorted. Keep in mind. Same strategy when we are dealing with other examples. So this is shortage is getting 0 volts, right? And this is V1 minus VT over 4. Okay? What else? What's the current going up? You got an IT, you got a V delta, merging, coming out. Okay? So what is that? So V delta plus IT is V2 minus VT minus V1 over 4. Because it's flowing that way, merging, going that way. So it's VT minus V1 over 4. Right? And VT minus V1 is what? Minus V delta. Why do we want to do that? Because we have V delta here. So we have to address that. Okay? I delta here, so we have to address that as well. So what's really happening here is 0 minus, because this is shorted, 0 minus V1 over 5 is what? I delta. That's all the equations we need to use. So what's happening is you look at here, I delta. You can use V1 to represent it. So this I delta can be gone. Okay? What about V1? V delta, plug in here, replace V delta is gone. If you put this one here, what's happening? You have IT, VT, V1, right? What you can do? What I'm trying to do. So I'm trying to build that kind of strategy. I don't want to just directly dive into it. And so next time when you are having the same problem, you don't know where to get started. So what I'm trying to do, find RTH. How do you find RTH? VT over IT. Okay? So eventually what you need is a long equation with only VT and IT there. So divide IT on both sides of the equation, you got a VT over IT on one side of the equation. Equals something. Done. Right? That's the goal. Do you need a V1? Do you need a V1 in that long equation? It's going to give you problems. Let me draw it to you. This is the goal, right? Keep that in mind. This is the goal. That's the goal. You have to be clear about your goal. Your goal is to get a job after graduate, right? In other industry, so you don't need to learn circuit one. Be anything but not a electrical engineer. So the goal is this, right? The goal is this. This is the goal. So eventually, the desired equation will be something IT plus something IT plus something IT equals something VT, right? That's what you want to see. Why? Because you divide IT on both sides of the equation and move this one here. Done. That's RTH. Make sense? That's the goal, okay? Now let's come back to this set of equations. How do we do it? We have this equation, the longest one. We can use that, right? I delta, so I have VT here already. I want to get rid of V1 I delta. So I don't want to get rid of VT. So get rid of I delta first. Here, I delta is gone. But still have V1, right? V1, V1, V1. So you can use these two equations to get rid of V1. Now let's do it. 1, 2, 3, 4. Let's see how we can do that. All right. So first, 4 into 1. Okay, 4 into 1. 4 into 1. 4 into 1. That becomes minus V1 over 2 equals V1 minus 13 times this guy. 13 times over 5. Make sure I'm not making a mistake. That's 2 ohms actually, not 5. I'm sorry, this is 2 ohms. So V1, this is 5, but this is 2. So 0 minus V1 over 2, not 5. Plus V1 minus VT over 4 times what? Times 20 on both sides. Okay. $35. Come back. Now dealing with these two guys. So 2 and 3. From 2 and 3, what you can get from that. V1 minus VT, which is V delta. Plug in. Times 4 on both sides. Move over. number 5, number 6. I hope I'm making this correct. Let's see. It's a moment of truth. From 5. Let's just directly from 5. We're getting V1 equals 9 over Vt. Oh, Vt over 9, right? Plugging 5, 9. Oh, no, that's right. Yeah, actually, that's correct. Vt equals 5 Vt minus 4 It. Not very familiar with these numbers. We'll see. You're not asking for a refund from the school, right? If I didn't get it right. See, 5 minus. Oh, so this is times 9 on both sides. 5 Vt equals but did you get it? Now let's come back. Take a step back. So which method we are trying to use to find out RTH when we have a lot of dependent source in it? We use a little testing current and testing voltage, and eventually we want to try to find out the Vt over It to get the result, right? Eventually you can find out it works. So the next step becomes the maximum power delivered to the output. So you can, this is already calculated. This is already calculated. You got adjustable resistor. What's the time now? Let me bring my watch. I have 3 more minutes. What's the maximum power? So maximum power P max RO equals something when RO equals RTH. How that is verified? So how to find the current power? The power is what? The power is V over RTH plus RO. That's a current. Current squared times RO will be the power. Okay. So that equals what? That equals V squared over RTH squared plus RO squared plus 2 RTH times RO times RO. Divided by RO on both sides, on top and bottom, you're getting V squared over RTH squared over RO squared, RO, sorry, plus RO plus 2 RTH. If you want this one to be max, these are 2 with the variables, this should be the minimum, right? Should be the minimum. How to find the minimum? D what is it? This is simple because you are having this is just a minus first power, so you are getting derivative of this one becomes minus 1 times RTH squared times RO minus second power plus 1, right? So this has to be minus 1, which is 1 here. Eventually you find out RTH squared has to be RO squared. So RTH has to be RO in order to have this one as the maximum power. That's how that's verified. Okay. Okay, so this problem is solved. Have a good weekend. See you on Monday.